operating system. So you already have the general overview of the mobile operating system, which is given by the Sandhya Rani previously in the previous lecture. So I will be starting with some mobile operating systems which we have, like Palmos, Windows CE, and Symbian. So first of all, I will be starting with the Palmos, which is a general purpose, which is a mobile operating. So let me introduce you first. I am Jntuk Rana. I've been working with TCS here. I have years of teaching experience and 4 years of industrial experience. So now we are going. Is my voice audible to all of you? Can I have that on my chat? Is my voice audible to all of you there? Can you please reply me back on the chats? Okay. Can you see the slides which I have opened right now? Are you able to see my slides? Okay, so we'll be starting with the Palm operating system. So Palm operating system. Okay, so Palm operating system is basically used for handheld devices like your PDAs. It's like personal digital assistants. So basically, this operating system is a minimized form of OS, which will be like porting to a small device, like your the devices which can be handled by your palm, right? So it is designed for a highly efficient and which is having the most productivity, small programs, and with few application tasks. Okay, we cannot run so many applications on these devices, but whatever the application we are running, the productivity will be small, but they are efficient enough to be for the user. Okay, they will be offering the high performance because they have the special feature here. What they support is they are supporting one process only. Palm OS is the OS which only supports one process, which controls all your computations with the help of event handlers. Okay, I will be explaining this how it handles your applications with the help of event handlers later on. But as of now, you should know, okay, there is only one process and one task which is running in the operating system. We don't have so many processes like in general purpose OS. We have so many process applications running parallelly. Okay. So as I already told you, this is a single process running within the OS. There is no multiprocessing and there is no multi-threading. And and this is basically compiled for a specific set of hardware we can compile it for. So its performance is very finely tuned for this, for particular specific hardwares. So the memory space, if I talk about the memory space is partitioned into program memory and multiple storage heaps. Give me 1 minute, there's some problem here. Okay, that's fine. So this Palm OS we have so now I'm talking about the file format in the Palm OS. So the file will be in the format of a database here, we will have the database here, and those files will be in the form of only database. And it also supports IP-based networking connectivity and Wi-Fi. That Wi-Fi is provided in the later versions of the Palmos. So 5.0, after 5.0 Palmos we have Wi-Fi connectivity. Wi-Fi features were there in the OS, and we can also connect this with the cellular GSM and CDMA technologies. With that we can have calls and all those stuff. So as I already told you, there is no multiprocessing and no multitasking in the OS, and this is basically simplifying the kernel of the OS. There is an infinite. So now I'm explaining you how basically your Palmos works. So since we have only one process in it, so that process will be running in the infinite loop. Process will be running in the infinite loop, and particular application from that particular process, there will be an event handler which is registered. There will be event handler which is registered prior to application running. Okay, so I'll be explaining that more detail with the diagram later on, but as of now you should think, okay, there is a one process which is infinitely running. If any other application wants to run, that application we will run by the help of event handlers. So what we are doing here is we are actually polling the events. We will actually poll the events. So there is a while loop. You think like there is a while loop. We will go through that while loop. We will polling each and every event which are already registered, for a particular sub application. So whenever we will call the event, we will call the event handler. If any sub application wants to run, call the event handler, and then your sub application will execute it. So those sub application is a part of your one application only, your one process only. Okay. So how it's polling happening here is polling for events at specific intervals. So we will be polling our event handler at a specific time of at a specific interval of time. So each poll event will generate an interrupt signal. Each poll event will generate an interrupt signal, and that signal will actually wake up your sub applications. Okay, and it will be handled by the event handler. So here these interrupts are not like hardware interrupts which can even masked. Okay, we can even mask the hardware interrupts, but these interrupts are non-maskable interrupts, and there is no priority fixed for the ISR, interrupt service routine. Okay, this is the function which will be calling your applications, which will be running on the behalf of your sub applications. So for a request to run an application or sub application, polling for the events. Similarly, if you want to search any program, we will be requesting for the process for a query of the event handlers. So notifications, your GUI applications, touching and tapping of the screen, all these are small applications, sub applications of that large process, of that large application. Each of these touching, tapping, all the GUI actions which you are doing on your mobile phones, like which on your Palm phone, that will be handling internally with the help of event handlers, and those are already registered through the ISR routines. So as I already told you, these slides were like repetitive slides, but I already told you that this compiles for a specific network hardware, and we are optimizing it to make it the footprint, memory footprint smaller, because we don't have so much of memory in the hardware. So this is a general display screen support, like what display screen support it can do. So it's generally a wide screen it can support, and the resolution will be 160 by 160 pixels, and layout is optimized for desktop programs displayed on screen. 256 color touch screen over there, and high resolution support in new versions. After 5.0, there are higher resolutions it can support. So now here is the RAM is 16 MB RAM. your RAM will be 16 MB, and your internal flash, which is your non-volatile ROM, that will be 256 MB, and your flash memory card, that is your SD cards, your your MMC card. Okay, so that those cards will be, it can support 256 MB of cards in this device. So can I have over on the chat, like which I can help you with? Is there any questions from other side? Am I audible to all of you, and like I'm going fast, or can you please reply me on the chat? Okay, thank you. So now we are discussing the memory space partitions. So your memory space partitions is like we will be having, so your like when process is running, it will make use of stacks, and your global variables will be used. So the running process will make use of the stacks, and if there is some memory allocations, dynamic memory allocations, it will use your heap memory. It will use your heap memory to allocate the variables if we are dynamically allocating some variables. Since we have lots of sub applications which are all running from the same applications, okay, with the help of event handler, as I already told you. So we need to have separate multiple storage heaps for data and applications, like sub applications here. Okay, so because event handler will go to the sub application, then sub application will have to maintain their own data, will have to maintain their elements from where they can actually allocate and deallocate the memory for their global variables own data. Okay, so this is the file format. So format of a database, I already told you, like file is a format in the form of database, and there will be multiple records, information fields about the file, name, attributes, versions of the database for the applications. So about the connectivity, we have IP based network connectivity here, it supports, and it also supports Wi-Fi in later version, wireless communication protocols, and integration to, those are just repetitive slides, I'm just carrying on from those. So Palmos APIs, this is application programming interface. So for application developer who is developing the applications for a OS, Palm OS, so those guys, those developers needs APIs to talk to your Palm OS. The features are provided by the Palm OS for the applications. Okay, like they want to talk to the scheduler of the Palm OS, they want to talk with the memory management, they want to talk with the process management. All these are different parts of a operating system. Process management, memory management, scheduling, your interrupt management, IO management, and your you can say your networkings. All these are subsystems of it. So those application developers needs the APIs for that. So we have simple APIs as compared to Windows C. So Windows C I will be covering next after this Palm OS. So simple APIs for developing the GUIs, graphical user interface. There will be the for buttons, menus, scroll bar, logs, forms, and tables. And we can also use HTML markup language here to develop our GUI applications. Okay, so desktop. Okay, so what are all applications which this Palm OS is supporting? So Palm OS is basically used for PIM. PIM is stands for Personal Information Management. So this Palm OS is basically focused on the applications which used to store personal data. So it will store the personal information. So like so this is how our application is there in the, it's like address book. It will store the addresses, like data book for tasks to do, what task we need to do, organizations, memo pads, Okay, SMTP, simple mail transfer protocol, and email and downloads. All these things are used by personal information management. So application will be like that only. Your office creation, sending of P3, that is post office protocol, which is used by the email actually, and internet browsing functions, Windows organizations, and PDAs. PDAs is a device, personal digital assistant, which will take all your applications as a personal information management. Query development supports. You can also develop the support for the like query based applications. So you want to search the database, so that those kind of applications you can also develop on this with the use of this Palmos APIs. So Palmos client side applications. So what we are using for GUI is GUI development support on C and C++ platform using Palm SDK. SDK is software development kit. So Palmos will have its own SDK kit. So by using this software development kit, the GUI developers, the application developers can use C and C++ as their language, as high level language, as their platform to work with this software development kit, SDK kit, which is provided by Palmos. Okay. Also support it also supports Java applications using J2ME, Java 2 Mobile Edition, and advanced tools, for example, macro work, code barriers, and all those. Multimedia applications you can also. Okay. Okay. Let me check this. Okay. Some more are also coming over here. So Palmos client-side applications, I already told you about C and C++ platform using Palm SDKs. Okay, multimedia applications such as playing music. Palmos also supports multimedia applications here. Now we come to communication part. How communication happens with Palmos. Digital and infrared ports for communication with mobile phones and external modems. And it will synchronize. If you want to connect to your Palm device, which is running your Palm OS, if you want to synchronize this with your personal PC, it will be using your HotSync application. HotSync is a sub application which is running from that main application, and so after resolving all the conflicts, so it will sync up your PC, that is your personal PC, and your device can sync up with the help of HotSync, and then you can download the data from your host to device, or from device to your host machine, your personal PC. And it also supports your IRDA or serial devices. Okay, so you can connect your PC through IR, infrared also, and with the help of serial ports. So HotSync, if once you've connected your HotSync application, and once that sync is done, you can actually drag and drop your files from your PC to device, and from device to PC, vice versa. You can do that stuff. So it supports multimedia cards as a memory. It supports SD memory card also. It supports secure digital input output memory cards. So this is the application layer in architectural. It's application layer and architectural layers of Palmos. So basically, you will have the hardware. Below hardware, like you have some like internet connection ports. Like through RJ45, you are getting the IP packets. Through RJ45 connector, you are getting the IP packets, which will be taken by your Ethernet controller, and those packets will be transferred to your operating system. Then operating system will actually transfer your packets to the networking stack. So networking stack, that is TCP stack. So here it also uses TCP/IP stack. That packets will transfer to your network layer, and then network layer will transfer the data to your transport layer. Transport layer will send the data to your application layer. That's how application will get the packets from your Ethernet ports. Application will process the data. So generally you have the hardware is like CPU, memory, all the ports like RJ45 port, serial ports, IRDA ports, and then modem. All these are hardware. Above that we have so what is OS? OS is generally an abstraction. From application point of view, application directly cannot talk or cannot access the hardware. So OS is actually providing the abstraction for the maximum utilization of the hardware. So if you're talking about the processing, or if you are talking about the memory, so you want a higher efficient use of the hardware. So we need an abstraction layer. So OS is nothing. It's an abstraction layer on the hardware side, on the hardware, so that application maximum there is a maximum utilization of the hardware and memory. So here Palmos is basically using microkernel. So now maybe you have the question like what is microkernel, and we also have monolithic kernel. So there's a difference in microkernel and monolithic kernel. Monolithic kernel are those kernel which have like all these segments like process management, interrupt management, your IO management, your stacks, TCP/IP stacks, all these are a part of same binary, parts of same binary. If something happens inside the kernel space, your whole monolithic kernel will go down. Microkernel is like these are separated, and like process management, memory management, and your scheduler for part of your kernel. Okay, scheduling algorithms, all the scheduling algorithms will be running by the scheduler. That is your core part of your OS. So these process and memory management, these are kind of subsystems, which so those will interact with the IPC communications with the help of inter-process communication, your kernel to your main kernel. So that is how they design this macro kernels. Okay, so microkernel will have like a layer kind of structure. It will be a layered structure. So below scheduler and then process and memory like this. So they will talk with the IPC mechanism. And here you have inter-process communication on events, string handling, real-time clocks, timers, alarms, sound. All these things are the part of your microkernel only. So kernel sits on the lowest layer in the OS, and then it interfaces to the assembler. So how your basically software runs, like your high level software like C, C++, they all compiled like if we have C, they will have C compiler for that, and it will be compiled to the assembly language, and then assembler will actually compile will transfer this to your object codes, and those object codes actually linked and with the help of linker, and then you will get the executables. Those executables we actually can run on your CPU with the hardware. So the kernel will actually provide all ABIs. One is API, application programming interface, and one is ABI, application binary interface. So once you will get the binaries, your executables, those should be compatible for the hardware. Okay, if those are not compatible for the hardware, your whatever the application you are compiling, because compiled for a specific hardware, you cannot compile an application on x86 for x86 and take that binary on ARM board and compile on there. So we need some ABI kind of support. So the hardware, so the kernel should also support your ABI interfaces. So there is a directly interface, so it also supports your assemblers, your compilers, and all those stuffs. So Palm OS is a microkernel. Okay. So now we come to the versions of OS. So Palm OS 4.x is having improved securities. It's having the support for GUIs, telephonic libraries, standard interface for access to the external SD cards for the files, and then Palm 5.x is having APIs for high resolution screen. We need high resolutions, so we will be giving some APIs within the Palmos 5.x, 5.10 like this. So advanced Palmos handheld. So these are some recent developments which are integrated in the Windows CE. Windows CE I will be explaining later on after Palmos. So now we come to the deficiency of Palmos. So the major deficiency of Palmos is there is no multitasking. There is no multitasking because there is only one application running all over the time, because it is an infinite loop, and I already explained that this will be calling with the handlers. So your sub application will be running from this. So the deficiency is does not offer much extendability, like it cannot be ported to any other device, and it not supports large number of devices. It only supports the devices which are suitable on Palm, like which are Palm device, because memory footprint is low actually in this case. 16 MB of RAM we are using here. So 16 MB is less as compared to other architectures and other OSs. So the summary of this is like, I'm just going through with the summary. So Palm OS is designed for highly efficient, small productivity programs, and it only supports few applications. It is one application, but within that application we will be supporting other applications as a part of sub applications. So it will not be there is no multiprocessing support here. So there is a difference in multiprocessing and multitasking. Multiprocessing means you are not using multiple cores in the hardware. So CPU is having one core only. If there is one core, that means your system is multiprocessing system. And if you have multiple cores, that means you are supporting actually multiprocessing. So if you have three processes, each process can run on different cores parallelly. So this is not supporting multiprocessing. So it is simple and file recorded as database. There is hot sync facility here. You can drag and drop your stuff here. This is the end of Palm OS part 1. Now I will carry on, and there is one more slide for Palm OS only. We'll go with that. So do you guys have any questions up to now, till now? Okay. Part of this Palm OS. So now I'm talking about the memory support, which is supported by the Palm OS. It only assumes 256 MB of memory, and the card, RAM, ROM, and flash memories. RAM will be 16 MB, ROM will be 256, and again flash is also your 256 MB. So we are using RAM for stacks. Stacks are being used by the process while it is executing. Okay, for global variables in the running process of the applications. Flash are used for storage of non-volatile data. If power also goes off, you will be having the data on your flash memory. So now, as per the memory we are concerned with in the Palm OS, the application which are installed, which are stored on this Palm OS, they are also using persistent battery backup as a RAM. So what is persistent battery backup RAM? RAM is like a volatile. Okay, generally RAM, whatever the data is within the RAM or goes off, the data of RAM will goes off. Persistent battery backup RAM. So there is a battery which keeps the data of RAM always there. So RAM is like we have cells within the RAM. So those cells are like that RAM will be formed with the help of capacitors actually. So capacitors will store the charges. So we need to refresh that every time. We need to refresh the charges to store the data into the capacitors. So those with the help of the capacitors, the RAM is formed actually. So in this case, we are using one battery backup for this RAM, because if power goes, your RAM data will go off. Your application can also store for a duration of time on the RAM itself. So if the data is in the RAM, what will happen? If the data is already there in the RAM, there is no need to load from RAM or from hard disk or from ROM, your non-volatiles, to the RAM. So in this case, your Palmos behaves faster. Okay, the running of application will be faster because we are taking the time from loading the data from hard disk to RAM. But in this case, the applications are already installed on where? They are already installed on RAM, because we are keeping that RAM data persistent with the help of a battery backup. Okay, your application will run faster in this case. So this is one major change in this OS. So we are using battery backup RAM here, persistent RAM here. How much dynamic heap supports? So I already told you that there are so many sub applications. So it will support 96 KB of dynamic heaps for each and every sub application processes. And stack will support 3 KB. 3 KB of stack, 96 KB of dynamic heaps. You know what is dynamic heap? Dynamic heap for dynamically allocating memory and deallocating the memory. While running itself, we need some memory for the variables. Is there any questions from the other side? Okay, we'll carry on then. So it is using it's use allocated dynamic memory buffers for input-output port devices. So static allocation of the memory will be like application which are already installed, like in the backup persistent backup RAM, the applications are already statically installed in there. When you power on your device, your application starts running itself, because there is no time gap, because it will not load the application from your ROM or from your hard disk or like kind of those. So this is faster. So file, there will be a concept of file manager. It will manage your file as a database, as I already told you, and it's in the form of multiple records and information and fields. Your records will have different fields, and all your file data will be stored in those fields of the records. So for example, like you have file attributes, application databases, modification number, access count for number of times, how many times the file is accessed. So all this information will be stored in the records of a file. So a local file is storing the table and uses file location local ID in the required order. So it will be like supporting you're recording the file in the form of order. So it will, if any data we wants to take out from the file, it will search that particular kind of, there's a kind of linked list kind of stuff there. So it will go on, carry on, and search the nodes and search and give the data back to the user. So communication APIs, it supports IAD and all those ports. So what all protocols it's supporting? This is supporting connection management, and it is also support modem manager. Modem manager for managing the data which is coming out from your packets which are coming out from your TCP/IP layer. So the modem manager will handle that stuff. Serial link protocols, all the serial data will be handled by the serial link protocol. Okay, this is not required actually. IRDA, it's a asynchronous serial 115 kbps. It will be the speed of the data transfer in IRDA is 115 kbps, and the synchronous serial communication, that will give the data of throughput of 4 mbps here. Exchange manager is behave as a session layer. So whenever you're getting the data from as a packets from the network stack, TCP/IP stack, so how your networking is done. So as I already told you, there is a TCP/IP stack in the OS. So that TCP/IP stack is like how is TCP stack is maintained. So at the lower side you have your network controller, and above that you have your network layer. Network layer is like IP layer, which will define your IPs. Then above that you have your transport layer. Above transport layer you have your BSD sockets. That's an interface. Through socket programming we actually program your applications. And so your socket APIs, with the help of these Berkeley socket APIs, we are actually making applications which will actually talk to your TCP/IP stack. Okay, so TCP/IP network stack will actually is like a library function. It will like suppose you have here we are using two transport protocols. One is UDP and one is TCP, user datagram protocol and transmission control protocol, to send the packets to the stack and to get the packets from the stack. So these two protocols will be used. So now comes to how application development is being done in Palmos. So the application development is like so first of all the application is like you have one application. This is the main part of this Palmos, how application development is being done in this. So we will be having event registered with the sub applications. Okay, and when we go through with that while loop with those events will actually call your event handlers, and with the help of those event handler, the event handler will actually signal your sub applications. Those will wake up your sub applications. So what does this application development mean in Palm OS? The application development means providing additional events, and we are coding for the corresponding handlers. So we have to write our own handlers, we have to write our own event handlers. If we have our own event handlers, we can actually put that event handler within the same application, and then we have written our own sub applications also. Okay, so once that while loop is going on, we will be calling that event handler. Event handler will call our actual sub application. So with that help of event handler, we can actually run our applications, sub applications. Now this is how your application development works. An application can be assumed to be divisible into sub applications. Like suppose you have sub applications from A0 to AN-1 along with their existing event handlers from A0 to AM-1. Okay, then next is assume that A0 runs on the events. So like okay, we will have event handler as E0 to EM-1. Okay, and A0 to AN-1 for sub applications. So those events are basically linked with your application, one event for one application. So when events are polled at a specific interval of time within the infinite while loop, your sub application will call. So this is how your application works. Sub applications will call. So this is a while loop which is running from I is equal to 0. Yeah. From I is equal to 0 to I is less than equal to n, and then plus plus. We are polling through events, and if there is an event defined for some application, it will call that registered event handler. Event handler will actually call your sub applications. If there is no events, then it will go for sleep. Will go for sleep for a specific interval of time. When again the while loop comes from starting, it will again check if that event handler and call your sub applications. So is there any doubt in this particular application development? How your Palm OS, how we can write our applications with the help of this Palm OS? Am I clear to all of you? If you have any doubts, you can ask any questions. Sure. So you want me to explain this application on how application development happens on Palm OS. Okay, fine. I'll be explaining this once again. So here we have sub applications. We have sub applications from A0 to AN-1. Okay, A0 to AN-1 are the sub applications, and there is only, I already told you, there is only one application which is running. So that application will be in the infinite loop. So we have just taken a variable from I is equal to 0 to I is less than equal to n. So we are kind of polling all the events, registered event for a particular application, sub application. If there is an event we found, and like suppose if I found, the application runs, if I found E0's event is there, so we will call the event handler which is already registered with that particular event for that sub application. Okay, so event handler is kind of a routine, is kind of function will call and which will call and wake up your sub application. If suppose E0 is there, E0 will actually call your A0, E1 is called your A1, similarly like this. Okay, so and if there is no events find within the while loop, it will go for a sleep for a duration of time. Like suppose E0 is not there, so there is the time interval defined for that particular event. Okay, after like for E0 there is a time interval of T0. So after T0 time again it will, after T0 time again the while loop comes into picture, and if then event is there, it will go and wake up your A0 application. Otherwise again it will go and sleep. So how we come to know about whether there is event or not? Okay, so now sub application, suppose there is a GUI, there is an application I'm working on, I opened that application from my Palm OS. So A0 application, like suppose that application is A0, my GUI application is A0. So that A0 application will definitely have some event handlers registered prior to development of that particular application, and it will also know its events, by which event I can actually trigger my application, my sub application. Like suppose my GUI is registered with, like GUI is A0 and A0 is registered with E0 as the event. So whenever I'm opening that GUI application, my event will trigger. So you know that while loop is continuously going on. So if E0 is able to find the E0, it will signal that particular application and run that application. So it will run the sub applications actually. Whatever the sub applications were there, if they are the icons within the GUI, it will run those sub applications. Okay, because we have only one application, and from one application only at a time, one application will be running only. So from that one application only, we will be calling sub application. Like if you are there are some icons on that application, those are called, if you are clicking those icons, those are called sub applications of that particular application. So those will have their own defined event handlers. Am I clear to you as of now? Is it clear? This slide is important for this Palm OS actually. So if you know the slides, this is how you can actually develop your application on OS platforms. Okay, thank you. So there are some applications we can actually run on our Palm OS. Palm OS supports. So one is your SMS, your address, card infos, hot sync, to-do list, security, data, date books and calendars, calculators, welcome book and clock, all these things. So these are all parts of your personal information management, PIM. Okay, so these applications are part of that only. So basically these handheld devices, these PDAs, personal digital assistant, will be having the applications which will be suitable for personal information. If I want to store my personal information, I will go with this Palm kind of devices and will store those information with me. So this is for what Palm OS is developed. So it supports SDKs and CDKs. So Palm OS, we discussed in this slide, Palm OS memory management, discussed about the partitioning of how the memory partitioning is done. Like we have 96 KB of heap memory, 3 KB of stack memory. Okay, we have 16 MB of RAM memory, 256 MB of ROM and 256 MB of flash memory. That is your SD cards, which user can actually put into your device, and it can store its application, it can run its application from the SD card also. Okay, and basically the application which are stored in this APIs within the RAM itself, because the RAM is persistent battery backed up RAM. So it will be faster enough because we are actually executing our application from the RAM itself. It will also support the network libraries, like I already told you, TCP/IP libraries is being supported by this Palm OS development method. How application development happens, I will discuss about this one, how it registered the events and how events called, and then how you are calling your sub applications from the applications. And it also supports the application development packages. Those are called software development packages. Okay, so this is the end of Palm OS. Now we will focus on Windows CE. So as of now, do we have any questions related to Palm OS? Because now I'm moving towards the Windows CE. That is a different kind of mobile operating system which is being developed by Microsoft. So you guys can let me know if you have any questions about Palm OS. So now I'm going to Windows. You can write me on the chats if you have any questions related to Palm OS, because now we are kind of comparing this Palm OS with Windows CE and see what is difference in Palm OS and what is the different thing in the Windows CE, what it all supports. Any questions from Palm OS? Okay, no questions. Okay, great. So we will be focusing on Windows CE. So Windows CE 32-bit operating system. What do you mean by 32-bit operating system? So whenever we say operating system, 32-bit operating system, that means it can actually access 32-bit. 32-bit is what? Like 2 to the power 32. That is 4 GB of RAM, right? So it can actually, the CPU can actually see physical memory of 4 GB. That is what the architecture, that is what your OS 32-bit stands for. So we can actually support 4 GB of RAM, physical RAM, within this 32-bit OS Windows CE, which is being developed by Microsoft. Whereas if you see the comparison of that Palm OS, that is only 16 MB of RAM we can support as a RAM, as a physical memory. So Windows CE is more, it's more enhanced. and it supports more memory. Okay, it supports more memory than the Palmos, and it is being customized for each specific hardware. That Palmos is customized and is compiled for a specific set of hardware. Okay, but this is customized and compiled for large variety of specific hardwares and processors in order to fine-tune the performance. So it also supports large variety, large number of hardware actually, as compared to Palmos. So this is compatible with a variety of processor architecture. Windows CE also supports your ARM architectures and all those architectures. Like we have so many architectures. So ARM is basically used for this mobile operating system as of today. There are lots of architectures which are being used. So we can actually port our Windows CE on ARM boards also. Compiled for a specific set of hardware. So since Windows CE is is from the Microsoft, and you guys know, like Microsoft is having more expertise in GUIs kind of applications. So if you know the GUI, graphical user interface, so it will behave kind of, it's kind of a computer like field. If you're using the Windows CE font, it will be like you're using your Windows 7 or Windows 98 or Windows 2000 on your desktop computers, on your general purpose. Those are general purpose, but this is mobile operating system. Why we're calling it as mobile operating system is because we have customized it. We have customized, and the memory footprint is very low for this. Okay. While it supports 32 GB of RAM, but the memory footprint on which Windows CE is going to take, because operating system will also run on what? It will also run on RAM only, right? So since it is customized and since it is compiled for that particular hardware, it will be taking less memory. Okay. So it will also support large number of Windows based applications available at the device. So this is the one of the version of Windows CE 4.x, 4.0, 1 and 2. After 4.0, they have started supporting the GUI applications, VUIs, telephone libraries, standard interfaces for access to the external SD cards and for the files. After in 5.0 version, 5.1 version, this supports non-volatile file system using flash memory, and then flash used instead of. So see, the Palm OS was using persistent battery backed up RAM, but in this case they're using flash memory actually to run their applications. You can also run your applications from flash memories like NOR. NOR is a kind of flash. From there also you can actually run your applications. That is more faster actually, but not as RAM. RAM is faster than NOR and NAND. So Windows CE supports a new file system that supports large sizes, removable media encryptions, and larger storage media. The flash file system saves the files. So we are going to save our files in the flash file system. So Windows, so we call it as Windows Embedded CE operating system. It is open and it is scalable. What do you mean by scalable? Scalable means it can be ported to a different architectures. As I already told you, so Palm OS is compiled for a specific set of hardware, but since this OS, this Windows CE OS is scalable, that means it can be ported to different architecture also. We can port this to ARM architecture, we can port it to other MIPS, Spark, or we have PowerPC, so many architectures are there, but we can port it there also. So it's a scalable kind of stuff. So it will be having small footprints. So small footprint means the memory footprint will be small. There it's going to be stored, and provides the hard real-time capabilities with the redesigned kernel and embedded specific development tools. So what do you mean by hard real capabilities? Real-time, you know, real-time means there the interrupt latency. The interrupt latency is fixed in this one. So if you are running some applications, you will be getting the response in a dedicated amount of time. Okay, that is you will be having some hard deadlines. You can't cross that deadlines. So this can be the Windows CE devices can be used for home as well as places, but the Palm OS can only be used for your personal information management kind of stuff. It can, Windows CE can also store your media, it can also store your shared presentations, and it also supports your cellular networks. Through cellular networks we can actually connect and we can actually make calls from our Windows CE device. So this is also suitable, this Windows CE platform is also suitable for mobile devices such as Pocket PC. So we have Pocket PCs, like PDAs is also kind of pocket, it's not a pocket PC, but it's a personal, PDAs are for personal information management only. So it is based on Windows CE and hardware such as personal digital assistant, PDAs and smartphones. So what kind of languages we are supporting here and what SDKs we are supporting here? Microsoft Visual Studio 2005 is being supported by this platform because it's from Microsoft again. Windows Mobile SDK by the Microsoft itself for creating the applications on this particular platform, for creating softwares for this platform, and then developed in Visual C++. Visual C++ is also being supported here in Windows CE. So Windows CE 5.0 is being provided with some specific set of applications. So here the major difference between Palm OS and Windows CE is like there we are only having one application which is running at all time in an infinite loop, and that will be calling your sub applications through the event handlers. But here we have so many applications. Okay, and why we have so many applications here? Because we can this is actually providing multi-programming kind of stuff. That means, what is multi-programming? Multi-programming means, since we have 32, it can support what, 32-bit operating system, right? So it can support 4 GB of RAM. So at a particular time we can actually store large number of programs, store large number of applications, but one program will be running at a time. Okay, so when that application, when that program will go in a voluntary sleep, or it will be waiting for input output IO, then another program which will be in the ready queue will pick up by the scheduler and it will again start executing. So in that way we are actually not wasting the time of CPU. CPU will be always busy running process by process, running processes which are there in the ready queue. Scheduler will decide what process needs to be run with the help of scheduling algorithms. So that is one difference within Windows CE and Palm OS. So do you guys have any questions as of now? Let me know if you have any questions. So it also supports GUIs for a specific set of processors. We already discussed about this one. Okay. So as to Palm OS, memory footprint of Windows CE is large. Okay, memory requirement is large for this one. So the minimum footprint of Windows CE is 350 KB. Minimum footprint of Windows CE. Windows Mobile 5.x, all user data in persistent RAM, and RAM to be used only for running applications. So in that case we are actually storing our application also in the RAM. In this case, RAM will be only used for running applications, which are at that time. So your RAM will not be used by the pre-installed applications. We can actually pre-install our applications by with the help of persistent battery backed up RAMs. Okay. So, and the other differences that can be scales to the requirement of device peripherals. So whatever the device peripherals we are actually connecting to this architecture, it can scaled. It can be we can make that compatible to the device peripherals, this OS. Okay, since we are here, now we will come to know about the processes. Since we are here, physical RAM is in this case. It supports, because it is 32-bit operating system. So device based on CE 6.0 can run a large number of complex applications, and it can run as many as 32,000 simultaneous processes. The Windows CE 6.0 provisions for each simultaneously running processes. It's 2 GB of virtual memory space it can support. 2 GB of virtual memory space. So what is virtual memory space? Virtual memory space is you have the computer cannot access your physical memory directly. Okay, so there is one more level of abstraction. That abstraction is being handled by your MMUs, your memory management unit. So CPU is actually generating your virtual addresses, and those virtual addresses are being converted by MMU, that is your hardware, and then it will map to your physical frames, and that means your physical memory regions within the RAM. So it can support 2 GB of memory, virtual memory space. So if we have the virtual memory concept, we can actually put large number of applications, a large number of processes within the same RAM, within the single RAM. And since CPU is having the virtual memory, because it is not directly accessing the physical memory, so the abstraction is being provided by the MMU. So MMU is basically giving the security, okay, for the applications. It should not corrupt the application, the region for other partitions. So partition will be different. So we can make different partitions, and we can put different processes and more number of applications within the physical RAM here. So minimum footprint of this CE is 350 KB, which will be very less actually in this case. So now you already know about that. In the general purpose, in the overview of operating system, you already know about what is thread. It's a basic unit of computation. Thread is a kind of part of a process. So you know, process is having its own process address space. So thread will also use the same process address space. Okay, so thread are basically kind of sharing the same process address space. The thread will have, but the thread, what is the difference? The thread will have its own program counter. It will have its own stack. We can have so many threads within the same process. What is the benefit of this, having more number of threads within the same application? The benefit is like I can run the code of that application concurrently. Okay, like suppose, take an example, like suppose there is one application which is kind of doing some calculations, and it is also drawing some progress bar on your computer. Okay, so that progress bar is only been incremented when your computation is done. So that means your computation process, your computation function, and your progress bar function should run concurrently, right? If those are not concurrently, then means your progress bar will not be able to show us the current, the exact and correct progressing of the computation. So we will be having two threads. One thread is running your computation, and one thread is running your progress bar. So in that case, so with the help of multi-threading only, we can achieve that stuff. Like suppose you have games. In games, you suppose take a balloon shooting. Balloon shooter games, like you have you are actually shooting balloons. So shooting the balloons is a GUI. So some GUI thread should be there, and then there will be a score. Score will be managed by some thread. Similarly, there will be some thread running different stuff. So each and every these threads should run concurrently. So within the same process address space, though these thread will be sharing the same process address space, but will have different functions within that application. Okay, and they can run concurrently. If they are not running concurrently, we cannot achieve the functionality of a kind of games or kind of progress bar example I already told you. Okay, so this is the basic, this is called multi-threading. Okay, so this also supports, this Windows CE also supports multi-threading, basic unit of computation. It's a thread. So thread runs concurrently. Okay. Deployed in smartphones. So this mobile operating system can be deployed, and it can be deployed on your smartphones. It can be deployed on your handheld pocket PCs with features like with features as digitizers in the human computer interface, HCI, portable media players, and touchpad. You can also include touchpads and touch screens with your smartphones here in this case. So now we will come to know about the layers of the Windows CE. So basically this kernel, the kernel of this Windows CE is divided into sublayers. One sublayer is consists of large part of the OS, okay, and another sublayer will be according to the hardware. So it's like on the top of kernel, on the top of kernel we will have some hardware abstraction layer, okay. Even though if your application wants to talk to your hardware, it first needs to talk to your HAL layer, your hardware abstraction layer, and then it will talk to your kernel, and kernel will actually talk to your hardware. So in this case we have two sublayers. So what is the use of that hardware layer above that kernel layer? So the use of that hardware abstraction layer is like we are actually implementing the functionalities related to each and every hardware, because see here the use of hardware abstraction layer. If there is no hardware abstraction layer, every time when we are porting this Windows CE to another architecture, we have to change our kernel, right? We have to change our kernel. But if we are separating our kernel from the device supporting softwares, like those are called device drivers. So all if device drivers are being done in the your hardware abstraction layer, then what will happen, you can easily port your OS from one architecture to another architecture, because there will be no modifications. Whatever the modification you need to do is you need to do in the hardware abstraction layer. So your hardware abstraction layer will actually call to your kernel, and then kernel will talk to your hardware. So that's how they're actually having more portability, and this Windows CE is more scalable. That is the reason they are more scalable. So they have two sub layers in it. Okay, is there any questions for me as of now? Is everything is cleared as of now? If you have any questions, please let me know. Okay. We'll continue again then. So Windows CE, the developers, how developers is actually working on this Windows CE is like they modify their kernel without sharing the changes with to the Microsoft. So they can actually modify, the developers can actually modify their kernel source, and they can actually change the source code with the help of because they can actually port this kernel, and they can actually modify this kernel for different architectures. So yeah. So again, Windows CE is a component-based embedded real-time operating system with deterministic interrupt latency. As I already told you, what is real-time operating system? Real-time system means you should have deterministic interrupt latency. If any application wants any feature or any if they are requiring for memory, okay, so that memory should be that memory should be given to the application in a specific interval of time. Like that should not vary. That should be deterministic. Okay, so this Windows CE supports that real-time operating feature of kernel. So it can be configured as a real-time operating handheld smartphone devices. It can be configured for computers, and it can be also configured for embedded systems as a real-time operating systems. So now we'll talk about some database, how they're storing the files. So it's a data format. Again, the data format will be they're using the database only as a, there will be object files, and you can actually automatically compress your files and decompress while loading itself. You can actually compress it and decompress it when you are loading the files. So compression and decompression algorithms it supports for the file. While that Palmos is not supporting that compressing and decompression features. So Visual C and C++ platform integrates use of WAP. So it also supports Visual C, C++, and it also supports .NET and parsing mechanism here. So for GUI application development, you can use your HTML markup languages, that are your high-level languages, and you can use your embedded complex APIs which are being provided by this Windows CE operating system. So since the Microsoft is doing more on GUIs, you can feel it like as a PC-like feeling. When you are doing going through your device, it's like you are working on your personal computers. But the main thing is you cannot resize your windows here. Whatever the window you have, you cannot resize it. So it will be providing with built-in microphone for voice recordings, and it will be VUIs, the video user interfaces. It will be having buttons, shortcut icons, menus, scroll bars, dialogues, forms, and tables. All these things will be provided in this. So for display, it will be a high resolution color display, and it also support touch screens. It is stylus keypads. By stylus, you can actually write anything on your touch screen, and Windows layout of desktop programs it also supports. So what all softwares it supports? Softwares for Windows. Okay, it also supports PIM, that is information management. Again, it also supports except PM. It also supports contacts and tasks to do. Smartphones features are also included in this one. Multimedia applications such as playing music, you can support all these things. So these are all desktop programs which you can actually support on Windows CE. So which ports it is actually so it is supporting USB and infrared port for communication device. Okay, USB is not supported by Palmos. Okay, Palmos only supports your serial ports and your infrared ports, and this is also supporting USB ports, and then Bluetooth, TCP/IP, Wi-Fi, or Ethernet LAN interfaces. It can also support Ethernet and LAN interfaces. So in that case, we are actually using HotSync as an application where we are actually dragging and dropping data from device to mobile, and mobile to your from PC to device and device to PC with the help of HotSync. Here we have active sync, so that will actually synchronize your mobile device data with the help of with the help of these communication methods like USB, Bluetooth, or PC infrared port. With these communications, USB, Bluetooth, and PC infrared port, you can actually synchronize your mobile data with PC by using this active sync application. So connectivity to other devices. So it supports USB 2.0. 2.0 is the version of USB. Now latest is 3.0 actually. USB 3.0 is the latest version of USB. So it also supports third-party applications like games, applications, mobile, e-commerce, stock trading, stock tradings, all those things, stocks and all those. Windows CE, so 3 states. So what are all deficiencies? Deficiencies of Windows CE. So it cooperates running of threading, but it does not support simultaneously multi-modal user interface. you are already you are speaking as well as you are looking. So those are kind of different tasks. Okay, so it do not support multitasking. It supports multi-threading only. I already discussed about multi-threading. So it adapts to different sorts of hardware limits, mainly because of two reasons: compiled for a specific set of hardware for very fine tunes. Large parts of OS offered in the form of source code first, and then adjusted to the hardware by the manufacturers. So we will be talking about Symbian. Symbian is more flexible to the hardware. So that's why Nokia is using Symbian as OS, so they can port that to different hardwares. So this is a 32-bit real-time OS from Microsoft. It customized for each specific hardware and processor in order to fine-tune the performance, and compatible with variety of processor architectures. And it's a like a personal computer-like feel. You will the GUI is being provided by the Windows, and that will be like personal computer-like feel will be there. Large number of Windows applications is available at this device, and kernel consisting of source code and hardware. So this kernel is basically consists of your source code and your hardware abstraction layer. So you have two layers: the kernel source code, and above that you have hardware abstraction layer. I already told you about hardware abstraction layer, what it will do actually. So the porting, the scalability of your kernel source is easy if you have some kind of abstraction layer. So if you want